Assalamu alaikum wa rahmatullahi wa barakatuh. In this lecture, where we will see the how to program bisection method for solving nonlinear equation using MATLAB. So all of you are familiar with the bisection method. That's why I have chosen bisection method for explaining using MATLAB. Now, all of you I hope that you have gone through the fundamentals of the MATLAB. The same program can be written by using Octave also. It will work in Octave also. So before starting the bisection method, I will just refresh you how to write the function handle in MATLAB. Let us define some function handle. For example, if we want to define a function handle f, for example, if we are defining a function handle f is equal to some at the rate. This is the way for writing this. F is a function of x. So what is the meaning here? F is a function of x. And what is that function? For example, sine of x plus cosine of x. This is the function. So this is how you can write the function handle. So f of 0. You know that sine of 0 is 0, cosine of 0 is 1. So 0 plus 1 is 0. So this is how you can write the function handle. With this notion in mind, we will explain how to program the bisection method. So you know that in bisection method, we will be given a nonlinear equation f of x. We have a nonlinear equation f of x. Then we will be having something like a limit a. Also, we will be having a limit b. Okay, and by using this limit a and b, we will calculate x's. Okay, this is the format that we have. This is the method that we have seen. So how to find the new solution xs? It is nothing but a plus b by 2 at the center. Now we will determine where the solution exists. For example, if the solution is between a and x's, then f of a into f of x's will be less than 0. If the solution is between x's and b, then we know that the solution, if the solution is between b and x's, if you multiply f of b into f of x's, then you will be getting something less than 0. That means there should be a sign change. So if you are considering the interval a and b in bisection method, then all of you know that to obtain the solution, we have to continue the iteration. So what are the parameters given? The function will be given. Okay, so let us assume a function f. Maybe that function is x square. For example, it is a function of x. The function can be given like this. For example, it is x raised to 2. That means x power 2 minus 2, for example. Okay, this is a function handle. Now a will be given, for example, a equal to 0, then b is equal to some 5, for example, and one more parameter also we will define. What is that parameter? The other parameter is nothing but the relative error. That means error between two iteration. When do you need to stop this iteration? For example, the error between the consecutive solution. For example, in the 10th iteration, you got a solution 2.5. In the 11th iteration, you got a solution 2.50000001. So the relative error between this 2.50000001 and 2.5 is very, very small. So at that point, you can actually stop the iteration. So when actually you need to stop this iteration has to be determined by using the error. So error can be given something like this. If you are defining the error like this, okay, so you see the error is 10 power minus 6. 1 into 1 micro is the error. So you have, I'm going to clear this, you have the function you have the A, you will be giving B, and you will be also giving error. Then you will find solution. Okay, then what is the solution? So you will be finding the solution. So this is how you are going to find the uh, these are all the inputs, and by using these inputs you are going to find the solution. So how to write this function? I have already written the function. I will explain that function. Okay, so all of you know that in the previous lecture we have seen how to write any function. For writing a function, the function will be having an output, it is having an input, it can be given any name. Okay, now I will just solve this by using the bisection method. Okay, now you see here the first step. I will be writing a function by using function command. Okay, function, I will open a new script from here and I will write the function command. And what is this? I want to find the solution of the equation. Okay, so the solution will be nothing but the root of the function. For example, if you are giving a function f of x, then the root of the function is nothing but those value, that is it is nothing but uh, for some value of x you will be getting f of x is equal to 0. That is nothing but the root of the function. And the relative error after how much error you can expect in your solution. Okay, that is nothing but the relative error. Okay, so you can give any name. You can give here instead of root you can give here r. Okay, instead of r error you can give re. Okay, any name you can give. And you should use the square bracket like this, because these are all the output of the function. Now I am trying to solve by using bisection method. So I am using a name bisection pos root. Okay, that means by using bisection method I am finding the solution. You can give any name. Okay, you can give br bisection root or any name, whatever bisection method. You can give bisection method, bisection underscore method, or bisection method, any name you can give, doesn't matter. Okay, but you should save the function with the same name as you have given for the function name. Now this is f. F is nothing but the function handle that I have discussed before, like this. So f, how to write this f? I told you f of x, this is a function of x and it is x square minus 2. You can give any function, sin x minus 2, sin x plus cosine x, anything. Okay, so this is nothing but the function, and you will give the interval where the solution lies. You know this a and b, you are very you know about this a and b. This is nothing but this a and b, where the solution is between a and b, and how much error you can expect in your solution. Okay, suppose you want very less error. For example, the error is 0.000001. That means your solution is very accurate. If you are just considering an error of 0.1, the solution is less accurate. Okay, so if you want more accuracy, you have to give this error very small number. Now it has been given, a is given, b is given, and the function handle is given. I told you that if a function handle is given like this, if you give f of 2, for example, it will give the value 2, for example. Here if you give f of 3, it is giving the value of the function. And what is the function? Function is x square minus 2. You can give any function. You can change this function also by writing like this. Okay, now you know that first of all you want to find where is the solution. The solution may be between a and b. So suppose you are giving an interval, then you are finding f of a. So how to find f of a? Because f is a function handle, it is not a simple variable, it is a function handle. You will calculate f of a, and f of a is stored in the variable fa. Okay, you store it in the variable fa. Now let us assume a problem. I will give you the example. Let us assume that a function is at the rate of x then x square minus 2 star x. Okay, minus 2 star x. This is the function handle. Now I am just giving a equal to 0 and b equal to 0. Okay, sorry, b is not 0, b equal to some value 5, 6. Okay, and I am giving error equal to I need a very good accurate value, so I use an error of 0.0001. Okay, so you are very clear with this. You can see here a equal to 0, b equal to 6. Okay, then error is very small, and you have a function handle which is x square minus 2x. Okay, now I am calling this function. What will happen, we will see. After that I will explain each and every step. So you have function f, you have already defined, you have defined error, everything you have defined. So you see the root is nothing but 3. So you got the root, and what is the error? Error is nothing but 0. That means it's very accurate solution. You just find f of 3. What will happen? Because 3 is the root of the solution. You see here f of 3 is nothing but, you can see here, 1 second. So f of, I think there is some small issue in this. Inshallah, we'll see. Okay. So let us define another function. With that I will explain. Okay. Let us define a function f is equal to at the rate of x. Okay. We will take one example with this itself. Okay, it is given here x cubed minus 4x. It is nothing but x raised to 3 minus x raised to 3 minus 4x minus 8.95. Okay, and it is not 4x, it is 4 star x, then only it is 4x. Okay, now you solve this. A equal to, it is given the solution root lies between 2 and 3, so a equal to 2 and b equal to 3. Okay, then we will see this is so the root is 2.7037. I don't know what is the answer. Yeah, 2.7031. Okay, 37 or 31 you can see here, 2.703, and it is accurate up to 2 decimal places. If you want more accuracy, you have to give very less value of error. Okay, now this is the relative error between 2 consecutive iteration. Now we will see how to program this, what is happening. So when you give the function, you have the function f. Okay, you have the function f. Then first of all, it will calculate, you have a, it will calculate f of a. See here, it will calculate f of a. F of a has been calculated, it is negative. Then it will calculate f of b. You see here, f of b is positive. So the solution is between positive and negative. So you know that the solution is between a and b. Now, there is a command here, if, and if f of a into f of b is greater than 0, so we will execute this. You see here, nothing happens. Why? It is because if f of a into f of b is greater than 0, then only it will execute. That is what if command. If means if this condition satisfies, it will execute. So if f of a into f of b is greater than 0, but here you know f of a is negative, f of b is positive, so it is not greater than 0, it is less than 0. That's why it is not executed. Okay, so if both are greater than 0, then it will display this message, error message, that no solution exists between a and b. That means you can type this, what is the required error message that has to be shown. Okay, you can set this. So whatever you are setting here, it will be shown on the screen. Suppose you are setting like this, and if f of a and f of b both are positive or both are negative, then the product of f of a and f of b will be greater than 0, and it will display on the screen that there is no solution between a and b. But here f of a is negative, f of b is positive, that's why there is some solution which exists between a and b. Now I want to calculate the error, I want to calculate my x's. Okay, so you forget about this for loop now. I will explain. First of all, my I equal to 1, I will set I equal to 1. I have to continue the iteration. That's why I am using the for loop. Okay, the reason for using for loop I have already explained to you in the previous lecture. So I set my I equal to 1. Now I calculate my x's. Okay, I calculate my x's. Evaluate this. My x's, I got something like 2.5 because my solution was between a is 2 and b is 3. So x's is a plus b by 2 is nothing but. Now we want to identify whether the solution is between a and x's or the solution is between x's and b. So for that, I will find f of x's. I will find f of x's. Okay, so if I find f of x's, I will take this value and find the function. Then it is f(x)s. Then I will multiply my f(x)s with fa. What will happen? If I multiply this with fa, if the number is less than 0, that means if it is negative, then there is a positive and negative or a negative and positive case. Then the solution is between a and x's. So my new a will be my old a. That means my old a is a, that is will be equal to new a. That's what it means. Okay, and you can see here my new b will be my x's. Okay, so my new b will be 2.5. Previously a was 2 and b was 3, and if this condition, it will not always will be like that. Sometimes it will be negative, it sometimes will be positive. If this condition is satisfied, that means if it is negative, if the product of f(x)s and f of a is negative, then new a will be our old a and new b will be our x's. But if it is on the other hand, if f(x)s into f of b is negative, if this condition is holding, then a will be equal to our x's and b will be equal to our old b. There won't be any change in the b. Okay, so I am going to execute this. So now I am in I equal to 1. So I am going to execute this. I executed this. Okay, so I will see what is happening. A is new a and what is b? You see. So now the solution is between 2.5 and 3. Previously it was between 2 and 3. Now we got x's and f of our x's, f(x)s, you see here f(x)s is negative and fb is positive, so the solution is between x's and b. That's why it has chosen a equal to 2.5 and b equal to 3. Now you see here, if I is greater than or equal to 2, or if I is greater than 1, we can say, or I is greater than or equal to 2. So for the first iteration, all of you know that we will not be calculating the error actually. In bisection method, we can calculate the error also, but You can see if you are taking any method like the regular falsi or something like that. In the first iteration, you will not be usually calculating the error. So you have to skip the first iteration in calculation of error. So how you can do this? You will not be calculating the error if I equal to 1. You will calculate the error only if I is greater than or equal to 2. So if I is greater than or equal to 2, then you will calculate the current solution and the previous solution, and you will calculate the error. That means how you will calculate this? You will take the current value minus previous value divided by the current value, and you will take the absolute value of this error. That means you will not consider it as positive or negative. So that's what the error of J. So this will be calculated only if I is greater than 1. So I will execute this, the whole loop, okay? Whole loop once again. Yes. So after execution of this loop, you will get A equal to B equal to like this, okay? Now, so after the second iteration, so you see here, after the second iteration, A is 2.6 and B equal to 2.7. So the solution is between 2.6 and 2.7. Okay. Now we will see. Okay. Now we got error also. We got error also. This is very, very important. You got the error. Now you see the error in the solution you can expect is 0.0476. But my error, I need an error of 10. That means I need an error of 1 micro, but this is not 1 micro. This is only an error of 10 power minus 1. So I need more accurate solution. So I have to continue the iteration. So I need to continue the iteration until the error become less than our preferred value, or if the error is above this limit. I have given a limit 10 power minus 6. If the error you are getting is greater than this limit, you will continue the iteration. You will never stop the iteration until error become less. That means if the error is greater than the predefined value, then it will continue the iteration. So therefore that we will be using while loop. So what is this while loop? So while loop is giving you if the error is greater than or equal to the set point. You have set some error as E. If the error is greater than this set value or a threshold, you will continue the iteration until the error become less than this. Okay, so this is like a for loop but with a condition. What is that condition? It is known as while loop. We will call it as while loop. And what is the condition? The condition is nothing but this loop will execute many times until the error become less than, or we can say that if the error is greater than the set value, this will continue the iteration. Okay, it will continue the iteration. Now you see here, so it will continue the iteration. So how it will continue? It will change our I. Suppose in the previous iteration it was just for only for I equal to 1 to 2. Now for I become 3, when now I is 2, when you stop at this point, whatever I have shown with the cursor here, the value of I, you can see here, the value of I is only 2. Okay. Now you will increment the I. How to increment the I? I equal to I plus 1. That means I was 2, 2 plus 1 is 3, and it will store in I itself. That means the value of the I will be updated. Similarly, your J was 1, your J will be incremented as J equal to J plus 1, and it will be stored in J. So it will become 1 plus 1. Previously you can see here it is 1. Now with this 1 it will add another 1. So 1 plus 1 become 2, and it will store in J. So now J become 2 after execution of this. Okay. So you can see here after the execution of this, I become 3 and J become 2. Now it will calculate the new x's and also f of x's. Okay, it will calculate this. Now if f(x)s into f of a is less than 0, you know this is the condition. If this is less than 0, a will be equal to a and new b will be equal to x's. Okay, so we will execute this. Next, we will also execute this. What is this condition? If f of x's into f of b is less than 0, that means the solution is between b and x's. So new a will be x's and new v will be old v. And you will calculate the error according to this. So this will be continued. I am going to execute. Whenever you are using a while, there should be a end also for the while, like for loop. Okay. So you will be having, okay, I will start again. F a equal to 2, b equal to 3. Okay. Now I'm going to execute the whole thing. You got it, answer. Okay. Now after this iteration, after when the condition satisfied, when the error become very less, that means when the error become less than when the error er become less than the given threshold value e, our iteration will be stopped. Okay, or this iteration will continue whenever error become greater than e, otherwise the iteration will be stopped. Now you can see we can after getting the solution will be x's will be passed into a new variable root, and our error will be passed into a new variable which is known as the r error, and these are our output, and we will be given here in the function or output variable. Now let us see, we will execute this. Okay, we will execute this. We have given everything, you got it. So you see here what is the root is given. Okay, root you have got it, r error also you got it. Okay, so this is how to calculate by using MATLAB. So this is a function now. So this function you can store anywhere, and you can copy this and call like this. Okay, if you just type it, you are getting the solution within seconds. Okay, so this is how you can program by using bisection method. Now another technique, you know that it is nothing but the Regula Falsi method. Everything is same, only few changes are there. So in the Regula Falsi method, you will be finding x's by using this formula. Okay, you need a, you need b, f of b, you need b, you need f of a, then f of b and f of a. So by using this formula, you will be, so in the previous program, in the bisection method, you have calculated x's as a plus b by 2, but in Regula Falsi method, you will calculate x's by using new formula. There is no other difference. So in the same program, if you just replace the equation for x's with the equation which is nothing but x is equal to a into f of b minus b into f of a by f of b minus f of a, then you will get the solution. Everything else is same. All the steps are same. Okay, and I have changed the name of the function. It's nothing but Regula Falsi. Okay, to find the root of the function. So all other things like finding f of a, f of b, everything is same. Okay, so it is nothing but x's is nothing but a into f of b minus b into f of a divided by f of b minus f of a. Okay, this is how you are calculating. Okay, now you can see here so in each iteration you'll be calculating like this. Okay, then I equal to 1 to 2, So I need to copy this also. I think this step is missed here in this method. So FA will be calculated here. Okay. Then FB will be calculated. Then XS will be calculated. So you can see here, this is how we are calculating. I think I will update here also. I will update in the program also. Okay, so don't worry. You can see here, also I can calculate like this. Here it is actually not required anyway. If you want to add this step here also, you can add it. Okay. So you can see here, I have added fa is equal to f of a. Otherwise, it will be obtained from here itself also. Okay, there is no issue. Now you see here, your a has been updated, b has been updated. Similarly, like this in regular Falsi method also, you can see here, you can add this fa, this f of a. In regular Falsi method, I think you see here this program. In this program, I can calculate x's by using, there is a correction here. It's not a plus b by 2. It is like this. And f of a and f of b can be calculated like this. Okay. So this is how you can calculate. The remaining steps, everything is same. Okay. So your a is updated here, b is updated, then you can say that your x's is updated. So each and every iteration it will be updated. Similarly, Newton-Raphson is something different. Okay, so that you can go through this and study by yourself, but I will explain to you a little bit. You can give the function like name like this, Newton-Raphson, or any name you whatever you want. So the outputs are root and the relative error. The input is the function, but you have to input another parameter also. You know that in Newton-Raphson method, you know both the function and its derivative. So suppose you have a function f like this, x cube minus 4x minus 8.95. Then you have to define f dash also. F dash is equal to, at the rate of x, you see x cube, what is the derivative of x cube? 3x square. So 3 star x square. Okay, 3 star, sorry, 3 star x square. Then minus 4. Okay, you have to input like this, then only you will be getting a solution. In Newton-Raphson method, actually you don't need a and b, you just need only the initial value, but I have given here a and b. By using a and b, we can say that whether the solution exists between a and b or not. Okay, so if f of a is less than f of b, x not equal to a, and else x not equal to b. Okay, you can take the absolute value, actually absolute value of, if absolute value of this number That means if the function value is very small, that means that that point will be very closer to the solution. Okay, so you can see if absolute value of f of a is less than absolute value of f of b, then x not equal to a. Otherwise, that is the meaning, else x not equal to b. So what is x naught? X naught is nothing but the initial solution. And you can see what I have written here. You can see the formula as I have written for the first two iteration. For calculating the error in a proper way, I have separated first two iteration. After that, I have written by using while command. Okay, you can go through this. So I hope that this is clear. Thank you for watching, and you have to practice this. Then only you can understand the MATLAB very well. So I recommend you to practice by using MATLAB or using Octave. The same program will work in Octave also. Okay. Thank you for watching.